Hi, I'm Dr. Calum Maccormick and I'm the Module Team Chair of SM358 The Quantum World, which is our third level quantum physics course. So that's the subject of this video, so I'll introduce the course, which is presented mostly as these three books here. The subject, as I said, is quantum physics, which you'll often hear is the physics of the very small, i.e. the microscopic world, such as atoms, molecules, and the subatomic particles. However, that's not really true, since we are, after all, made of atoms and everything around us is made of atoms. We are effectively talking about the entire world here. So quantum physics, yes, it does describe the microscopic, but really it's about everything. More practically, modern technology such as quantum computing is developing to the point where soon we will have macroscopic objects, quantum computers, which are definitely obeying the rules of quantum physics. So this is becoming a very, very hot and modern topic to study. Okay, the course is presented in three books, which I will take you through right now. Book one is Wave Mechanics. Here we are, Wave Mechanics. So book one is about the basics of quantum physics. Here you'll see how the quantum system is described by a wave function, and you'll meet Schrödinger's equation, which is the equation of motion which governs how the wave function evolves in time. In this book, you'll see how to apply these ideas to very simple situations, such as the infinite square well and the harmonic oscillator, and you'll also get to meet quantum indeterminism and the Heisenberg's uncertainty principle. So book one there really about the basics. Book two is called Quantum Mechanics and its Interpretation. So here we're going to do a little bit more on the mathematical underpinning of quantum mechanics. So you'll learn Dirac's, Bra and Ket notation, and you'll learn about things like angular momentum, which you'll later need to describe atoms and molecules, and you'll also learn about how the uncertainty principle gives rise to the idea of indistinguishability, which leads to a concept such as fermions and bosons. One of the key outcomes of this is you'll discover the the Pauli exclusion principle. Okay. Right. So with that stuff done, you get to the end of book two, which changes tack a little bit, and we touch on quantum entanglement, which some people consider is the most quantum of all phenomena. Quantum entanglement is a fundamental aspect of quantum computing, and in these books, which are a little bit old now, we'll be discussing how quantum entanglement plays a role in quantum cryptography, which was very much emerging when the books were written, and another exotic idea, quantum teleportation. So that's book two. And finally, book three. Here we go, The Quantum Mechanics of Matter. Here, as the title gives away, we're applying quantum mechanics to systems such as atoms, molecules, and solids. So we'll start naturally with the hydrogen atom, and then you'll learn two very powerful techniques. One is called perturbation theory, and the other is called the variational method. And you'll use these to study molecules, which are obviously more complicated than the hydrogen atom, many electron atoms to an extent, and also some basic properties of solids. At the end of that book, you'll also study the interaction of light and matter. So that's the books. In addition to the books, our very experienced AL team, Associate Lecturers team, give tutorials on the major topics, and they will also use their experience to guide you through the course by marking and giving feedback on your TMAs. So let's talk about the assessment, which is the final thing I'll discuss. So the assessment on this course is a single 3-hour exam at the end of the course. That's quite daunting. So on the way there, you'll do 4 TMAs, tutor marked assessments, which will give you the practice you need to succeed in the exam. And there will be 7 ICMAs, or interactive computer marked assessments. Now, although 100% of the exam is where your score comes from, you have to get 30% in 2 of the TMAs, and you have to pass 5 of the 7 ICMAs to reach this threshold criteria for passing the course. So they don't contribute to your exam, but you do need to do these assessments. So that's the lowdown on SM358, The Quantum World. It's an incredibly enjoyable and rewarding course, and I hopefully look forward to seeing you take it. Okay.